So we're going to try something a little different. I'm actually going to start off with a demo because the worst that could possibly go wrong is that I take up this entire time trying to troubleshoot what's going on with my demo. But if it all works out, then I can get to the presentation, or not. It doesn't matter. But just to give you some background, the talk that I am delivering today, it was supposed to be a joint talk with my co-speaker, Rotem, but she wasn't able to fly out here. So I am taking on her parts and my parts, and it's going to be very interesting. The other thing, too, is the background for this talk is really around conformance, security requirements, compliance, meeting certain standards for building software, and then deploying that software into secure infrastructure environments. So there's a few key themes here, and it really comes down to detection and remediation. So we have to detect whether or not there are any sort of issues inside of our code base. We have to detect whether or not we have credentials that we've populated in our code space as well that might grant access to resources we don't want others to have access to. And then other things like, okay, when we have these services running in our environment, how do we ensure that we mitigate denial of service attacks and prevent unauthorized services from communicating with others. So the mindset here is to think about security first and shift your security as left as possible. So you want to start with the software developers all the way out to when you deploy your software into production. So what I'm going to start off showing you all is a basic Kubernetes cluster, and we're going to assume that we've already built the application and we've decided we want to deploy it to this cluster. So just to verify, I run a kubectl get nodes, and we've got a 3-node cluster. It's actually a Civo Kubernetes cluster. I just have to say that because I'm Civo Navigate, right? So it's a Civo Kubernetes cluster, but it's also, let me show you, running Cilium. So it's running Cilium, the CNI, the Container Networking Interface, and it's primarily because Cilium provides some functionality that I need. I'll need it very shortly. I'll talk about it in a second. I've also got Istio there. I decided not to experiment in this demo with Istio, maybe another time, because this is also the first time I'm ever giving this talk. So you all are my guinea pigs right now. That being said, what we're going to do now is we're actually going to use a tool. So I also have an application deployed. It's called the Book Info application. Some of you might have played with it at some point in time. Standard web app, very stateless. It just basically has a front end. It pulls data from several backends and then presents that data to us. I have nothing configured other than deploy the app. I don't have any policies. I didn't think about security whatsoever. Now, if I go ahead and run a Kubescape scan -- verbose, I'm going to use an open source tool by Armosec called Kubescape. And what it's supposed to do is it's supposed to deploy a few resources into my cluster, and it goes on to scan my cluster to determine whether or not I'm conforming to CIS benchmarks, if I am conforming to NSA standards, or if I have any sort of considerations around MITRE attacks. So when you consider these different vectors for security, what Kubescape is trying to do is determine whether or not you have any of these kinds of vulnerabilities. And it's going to tell you about that. So let's go ahead and run a quick scan. It'll take a few minutes. What it's going to do is it's just going to scan a variety of different resources. It's going to scan all the pods. It's going to scan all the services. It's going to scan for network policy, identity. It's going to scan to see if the Kube API server is publicly available or accessible by anyone. It's going to do a number of scans just to see where those security holes are. Now, based off of, interesting. Maybe this is not going to turn out the way I expected it to, but we'll see. We'll see. So based off of this report, right, it's telling me about all the different controls. And when I say controls, there's actually a published set of controls that Armo maintains around different standards you'd want to align to. But there's all these controls that we're trying to understand what we haven't configured yet, or what we might have misconfigured, or what we plan to configure down the line. So what Kubescape is telling us is, okay, these are all your security holes, go fix them. What's interesting though is that it's not just one tool that can do it all. There's not one tool that can provide you the identification of the vulnerabilities that you have in addition to remediation. You can think of Kubescape as a detect and partially respond, because it'll give you examples as to how you would want to approach this. Obviously, you'd have to work with your security teams to determine whether or not this is the right approach. And you'd also have to consider other applications you might be impacting if you decide, hey, I'm going to deploy this policy, or maybe lock down ports or something like that. What we're going to do actually is we're going to try and increase this particular score here, a non-compliance score. So the reason why my score is so low, obviously, is because I have a bunch of defaults. I haven't configured certain normal security practices that I would. I think a first good step is like, have I even configured a zero trust policy, a policy that prevents unnecessary east-west traffic? So what that means is, with my CNI today in its default configuration, all pods can communicate with each other. Let's take a look at that. So I have a command here that I ran. So not the apply. So I'm going to run an exec. So I'm going to basically exec into a particular pod and just query another pod for its output. And I'm basically just limiting that output to the title of the web page. Now, this should work fine because I have no policy in place. But if we further look up here, right, let's look for the actual control. There's a control here that says egress and ingress blocked, and it says the severity is medium. And it says that because I actually haven't implemented. This is for Trafake, by the way. You can actually look for the other ones. Let's actually look for our deployment. Okay, so product page, this is a perfect example because this is a deployment. And you can see that there is a control here that it's not conforming to for ingress and egress. What that means is, because you have no policy for default deny all in place, your score is going to be lower, which means you're missing a control. You've got, a potential for east-west exploits. So let's fix that. How we can fix that is just using a standard network policy. The thing is, we have to have a CNI that supports that policy. So if we go over to this is actually the Kubernetes docs, by the way. I just went to the Kubernetes docs, picked an example, and this is a default denial policy. My policy type is ingress egress. I haven't specified ports that I want to allow communication to, or any labels, or any sort of CIDRs or subnets. Now, with this policy in place, nothing should be able to communicate. So let's go ahead and apply it. I go back to my terminal. If I clear my screen, and if I do a kubectl apply -f, this policy is going to get applied to the default namespace because that's where my resources are. So I've got my policy deployed. If I do a kubectl get netpol, it's there. Good to know. If I do a kubectl, actually, no, I don't want to do that. Now what I want to do is the kubectl exec again, because the last time I ran it, we can scroll up and even see this. When I ran this kubectl exec, this was the output. Title, simple bookstore, and then the title header or closing header. So I go ahead and rerun this kubectl exec, and it shouldn't go through. It won't go through. And it'll sit there thinking, and then eventually maybe it'll just time out. That's just network policy in action. Now, I can give it a few more seconds, but really the output's not going to change. Now, if I rerun this kubescape scan command and verbose, my score theoretically should go higher. It will only incrementally go higher because I've only addressed one control, the network policy. But the reality is, as you start to, pick away at all the different controls that you are not conforming to today, you'll start to realize, like, okay, here's a model that I should conform to for every cluster that I deploy, as well as for the workloads. By the way, Kubescape is not just simply for scanning your workloads running in Kubernetes and the associated resources. It actually goes on to scan the images that are deployed to Kubernetes. So your container images, for example, if I pull them from Docker Hub, what Kubescape will do is it'll actually go on and use this open source tool called Trivy to scan the container image, to check for vulnerabilities. If there are vulnerabilities, it'll let you know about it so that maybe you might not want to use that image. Maybe you'll wait for a patch and then deploy that patched image. So I haven't rerun the, oh, wait, did I rerun the scan? I did. I think I did. So now if I go to the particular workload, the deployment product page, wherever it's hiding, I actually shouldn't see that ingress egress blocked policy. Here's the other thing too. So other controls for other services will fail because the policy that I applied was to the default namespace. I would either have to do a cluster-wide policy, which is something Cilium supports today, to apply to all resources for ingress and egress, or I could do this at a per namespace basis or at a host level if I want to. So let's go here. This is deployment. Deployment's an equally good example. And I don't see an ingress egress blocked control failure, which means our policy worked, which means we're taking the right steps to actually lock down our systems and conform to CIS benchmarks and other standards. All right, that's the end of the demo. We are done our talk. See you later. Actually, no, let's move on to the presentation. Okay, so the key thing I wanted to demonstrate for you is that this is not something you would do manually. Obviously, you're not going to sit there and have access to your Kubernetes cluster. You're not going to run kubectl commands. You're not going to run Kubescape. You're going to run this through your CI/CD process and probably use something like GitHub Actions if you're using GitHub, right? GitHub Actions where you can deploy Kubescape as what's the term? It's a worker, right? In GitHub? Something like that. So you deploy this worker, and as part of your CI/CD process, as the code is actually going on to be containerized, there's a scan done. There's actually a code repo that's scanned beforehand to check for, like, if someone left their passwords or credentials, or if someone, messed up a configuration somewhere with the way they built their application, or if they didn't conform to a certain template. Kubescape can be configured to catch that. Obviously, you're not going to sit there and use open source technologies for your production environments. You want to use the enterprise offering. So go check out Armo. We'll talk about that in a second. The second thing I wanted to illustrate is that while you do have tools to help you detect and provide suggestions on how you can remediate, you have to also consider the right tooling for how you would mitigate, how you would prevent, how you would ensure that you can enforce any sort of controls that have come up, right? So we saw one example with network policy, but there are elements around TLS and identity. There's elements around encryption, authorization. Even if we're using network policy to block and filter traffic, that only happens at an IP level. We also have to consider the HTTP level. And this is why when you're thinking about building a security and network stack for, let's say, your Kubernetes environment, you would use something like a service mesh paired with a CNI, paired with other elements as well, like GitOps and whatnot. Argo CD might be an excellent example of how you would GitOps your network. That being said, let me switch over the presentation. I really want you to realize that if you're really going on the path of detection and remediation, go the enterprise route where you could consider working with Armo, or there are other vendors out there too, that allow you to use a SaaS-based service that hook into your clusters. And what happens is they actually deploy resources into your clusters to do continuous scans from a variety of different angles, and even allow you to do in-cluster remediation through the platform as well. So it's pretty powerful. Okay, so like I said, my co-presenter is not here, and that's fine. I don't know why it's showing this. Let me stop. Did I mention y'all are the guinea pigs for this presentation? Right? Yeah? Okay. All right. Awesome. So my name is Marino Wijay. I'm sorry I didn't introduce myself earlier on. I intentionally did that because I wanted to focus on just driving this point across around detection and remediation. Back in, I don't know, April or something, I reached out to Rotem and I said, hey, let's do a talk together somewhere and focus on security, because I think Service Mesh and CNI provide the functionality to enact and enforce, but if you don't have the insights into your environments, if you haven't done any sort of baseline pattern matching or trying to understand how your workloads talk or how they communicate, you're not really going to know where to start with your security policies or your posture for that matter. So we decided to come up with a talk to give you ideas as to where you want to start. I'm not going to introduce Rotem, but I'll introduce myself. I am not a yoga lover like she is, but I'm all about the gains, even though I am not muscly today. I'm sorry. I have an extensive background in networking and I transpose that background into the world of developer advocacy. So I'm a developer advocate for Solo, as well as in the open source world. So let's tell a story for a second here. So you have this platform engineering team that has been operating a virtualization environment for a very, very long time. The business has come in and said, look, we need to operate and move faster. We need to iterate faster. Our developers can't wait on that virtual machine to pop online. Containers need to enter the chat. Perfect. However, because of our business requirements, we can't allow data to be exfiltrated anywhere. We can't allow data to be leaked. We cannot allow any sort of PI, personally identifiable information, to be exposed in any way, shape, or form. And oh, by the way, we do have a global network, so all of our communications need to be encrypted. We need to adhere to a zero trust policy and model. So when you think about that, that's a tall order coming in from your leadership team. Where do you start? So I kind of showed you where to start, but it's not just about starting. It's also about thinking about why the business requires certain things, what tools, what options are available, what platforms you use today, what applications you use today. Are they stateful? Are they stateless? What are those specific application requirements? Do you have any sort of static requirements that cannot be changed? There are so many considerations when you have to start thinking about a platform that is suitable enough to take on a lot of this. So let's assume Kubernetes happens to be that platform. It offers a pluggable architecture that you could take pretty much anything in the cloud-native ecosystem and plug it into Kubernetes, and it'll work pretty damn well. Obviously, you have to tune it, tinker with it, and make it a little bit better. But with Kubernetes and associated tooling, with the advancements in the world of eBPF, I think detection and identification, classification becomes very easy. Profiling becomes extremely easy for how your workloads run inside of your clusters and outside of your clusters, for that matter. So when we hear Kubernetes, it's like, okay, let me just throw a YAML at you and then everything should work. But that's not the reality. Let's be real for a second. If you decided to spin up a cluster and you handed your developers access to the kubeconfig, what do you think might happen? Right, okay. So while cloud native has associated benefits, the scalability, the reliability, the agility to be able to just iterate quickly, the biggest challenge as that complexity rises is security, because you have so many moving parts that need to trust each other. And if you have this one moving part that's untrusted, it's doing something, it's vulnerable, and then injects further vulnerabilities into your own environment, we know where that goes. So let's talk about some of those particular vulnerabilities that we want to consider and who needs to focus on that. Obviously, developers need to do their part. They don't have to be the ones that curate and manage Kubernetes security, but they need to be the ones that curate the security of their code and follow the security best practices for their software development lifecycle. Then you have platform teams that are responsible for deciding, like, what are the best solutions? What are the trade-offs I have to make in order to take on these security platforms? Do I lose a lot of speed in favor of that complete security? Listen, encryption adds overhead, which means that increases latency in our application response times. So that's a consideration, that's a heavy consideration, especially in environments like high-frequency trading, for example, where MTLS hurts that whole situation. Trading is a different beast, right? And then you have security teams that need to provide guidance, and they're the ones that are going to decide these are the controls that we follow. So based off of these controls, let's say MITRE, NSA, and CIS conform to those standards, well, we already know of a tool that can do that for us today. So what is it about cloud native security that we have to care about? I talked about a few of these, like preventing leakage. We need to ensure that we're conforming to compliance. With our CI/CD systems, we need to make sure that only these authorized systems are allowed to both talk to our repos in addition to the environments that our workloads are landing on. I mean, we don't want operators or developers to have access to any of this. They should just push their code, and operators should be able to just observe and see what's going on. You also have to conform to this model where it's not just virtual machines or not just containers or not just bare metal workloads or WASM functions for that matter. It's a combination of all of this. It's a combination because not everyone starts with containers and continues with containers. Some started with bare metal and they couldn't virtualize it, so they're stuck with that. But it might be their ERP system that runs their billion-dollar business, and if they try to virtualize it, it'll fall over. Or if they try to containerize it, who knows what could happen. So with all of these different areas and facets, there's these areas of security we have to consider, but there's also more. So misconfiguration is a massive concern for us. And this is why we automate, because we don't want to sit there and manually configure everything. If you were in my Network Foundations workshop earlier on, you would have realized that by configuring a network namespace manually for every single pod container that you have to deploy into Kubernetes is not practical, because if you make a mistake and 2 network namespaces have the same IP, well, what happens there? We don't want to get into that. But the point is preventing misconfigurations. Secret management. What model do you use today for your secret management today? How do you maintain your certificates? How do you rotate your certificates? Are you using a CA that you manage, or are you using a public CA? Do you have control over that CA? Do you have intermediaries? Are you using a service mesh that helps distribute these certificates to your workloads, both virtual machines and containers? So there's so much consideration around the credential side of it as well. If you haven't locked that down or provided a policy for your developers in how they access resources or bake credentials into some of their apps, that's a problem, and that needs to be mitigated. A lack of observability is another killer. Imagine if you were just running workloads and you just didn't know what was going on. You had no tooling, no instrumentation into your workloads as to how you can capture tracing data, log data, to determine whether or not a denial of service attack is going on. So usually you have to think about the way data moves, and then you also have to see how that data moves with the tooling that's available. I talked about images. You can mitigate that through image scanning. I mean, I worked at VMware at one point, and I think they open sourced a technology called Harbor, which actually uses Trivy and Claire to do container image scanning. You could either point it to your container registry, or you could actually have containers loaded into Harbor that you can scan, because Harbor is a container registry as well. But the idea is, if you're not using a golden image, if you're using an image that you decided, I'm going to run kubectl run nginx, and it's just going to pull a random nginx image because the DNS translation translated to a destination that wasn't Docker Hub, it was some other registry. So now you have this malicious container that's running in your environment because you didn't use, let's say, filtering to pull from the right registry, for one, and 2, because you also didn't scan the image that you pulled down into your environment. So that's another consideration with respect to cloud-native security. There's a few more. It's the reliance on the cloud. If you are doing cloud-native in the cloud, there is an assumption sometimes that the cloud is secure. That's not true at all. In fact, when you think about the model that, let's say, AWS or Google provide, they give you infrastructure, and then they give you instructions to tell you how you manage that infrastructure through best practices. They also give you guidelines in terms of security best practices, like use IAM, so that each service is authorized to use other services, and other services are unauthorized. So if you think about it, you are the ones that are going to be responsible for implementing that security model as you operate in the cloud. If you haven't, and all of a sudden there's a breach, well, sure, you could try and blame AWS, but guess what? They're a multi-trillion-dollar company that has a ton of lawyers, so they'll find ways around it. And this is why they publish guides around best practices. I can't remember what's called, the Well-Architected Framework by AWS. Go check that out if you haven't seen it. Networking. Okay, this is my domain. So with networking, it's very complex, but also can be very simple. But the more complex you get with a network, the more scale you have with a network, it comes with its own associated challenges. For example, what happens when I am running a virtual machine environment and I need to run disaster recovery procedures because that environment just failed? Well, did I have a backup environment to run those workloads? Are they going to have the same IP addresses? Can I still communicate with them? Is my security policies going to still be in place? Now, networking also provides an opportunity to misconfigure things. And this is why I might have mentioned it earlier, where you should be GitOpsing your network as well. And what I mean by that is, no, I don't want you to tie Git and a controller directly to your physical switch. It means that everything above that physical switch, from your operating system to, let's say you're using a software-defined network, to CNI and service mesh, and even maybe some API gateways, that's all going to be defined as YAML or some form of code. And if you define it as such, well, then you get to take advantage of tools like Kubescape to be able to scan if there is any misconfiguration. The element of policy is critical, because if you don't implement a default denial policy, obviously everything has free reign to roam around. But once you've implemented that, how do you know how to start unlocking things or opening up ports? So you wouldn't use Kubescape to determine that. You'd use other tools. You'd probably use a network mapper, or maybe you would actually profile your system by running it through Kiali, so you can see the service-to-service interaction. You need a service mesh for that because of the tracing data that you need to extrapolate. But by identifying all of this, now we can implement authorization policies. We can decide that we'll deploy MTLS, so we can authenticate our services. We can encrypt our communications. We can deploy layer 3 and below network policy as needed. And, oh, by the way, we can do DDoS as well, DDoS protection. So there are considerations not only on the misconfiguration side, as well as your secure code and making sure that you haven't uploaded like credentials so that people can steal. It's also the networking side of it too. Yeah, the moment you decide you want to learn more about Kubernetes networking, you start to realize that it can become very complex. I already talked about MTLS and config drift, but I want to paint a picture for a second so that you can get a sense of how your network should look like. I mean, this is my opinion and my interpretation of how a network should look like. But if you pick the right set of stacks and then you're able to pair that with Git, now you can GitOps your network. And now you've taken care of the configuration drift, the lifecycle management, the misconfiguration, automation of policies, easy duplication of policies across multiple environments, and then also build in and instrument your observability as well. That being said, this is not the silver bullet for running an application network that will conform to any sort of security standards. But with this, I mean, you'll have a pretty damn good start. I mean, you also have to think about the CA. You have to think about what kind of GitOps controller you're going to use. Are you going to use Argo or Flux? And so many other decisions, right? In any case, think about Kubescape for a second. So Kubescape, you input YAML, you input your repos, you input Kubernetes, and output is what is wrong security-wise. And that's pretty damn cool with that control library, because that library will continue to expand as they continue to see more and more use cases come out of a lot of these security incident reports and whatnot. But in addition to that, the ecosystem that they depend on is the tooling that enforces this. So service mesh, open policy agent would enforce authorization policies. You would use Spire and Spiffy to enforce workload attestation. Sorry, I have trouble saying that word for some reason. I don't know why. But tracking identity of workloads is something that is another critical aspect of your environment too. So Kubescape on its own does a fantastic job. But if you take it to another level and use Armosec's actual SaaS platform, it could actually spit out detailed reports around what you could additionally do to remediate a lot of these missed controls or misconfigured controls. And then having that information, right, you could decide how you want to approach how you fix Kubernetes, how you fix Cilium, as well as how you fix, let's say, your service mesh. Maybe you might be using Istio. You should be using Istio. You shouldn't be using anything else, but that's another conversation. Anyways, Kubescape is the recommender. It's the security profiler. The enforcer are these other tools that you have to decide. And this is not extensive. Let's be real. There's Inspector Gadget that can also provide some security capabilities. There's Pixie that gives you some deeper observability. Hubble by Cilium also gives you another observability angle that marries requests to TCP and UDP flows. So that should give you a different angle of maybe where an attack is originating from. So security doesn't stop at scanning, observing, detecting, and then remediating. It's an ongoing life cycle and process. So we shall shift left. I will end with one last diagram so you can visualize how all of this flows. So we have 4 security gates here. We have the gate from when we have to actually write our code and upload it to a repo. So there's some scanning that has to go on there to determine that our code is safe and executable and it has no known vulnerabilities. We have our repo that has this ability to now be CI/CD'd, so effectively containerizing all those artifacts and turning them into artifacts that can be run somewhere. So we have to gate that and determine whether or not we should be building with this type of image or use a different base image for our containers, for example. And then basically verifying and determining if everything is suitable for deployment into, let's say, a Kubernetes cluster or some sort of environment, orchestration environment for that matter. But then when we actually get to that last gate over there, this is right before we deploy to Kubernetes. Have we deployed a conformant Kubernetes cluster that has the right set of tooling to allow us to meet all these standards, all these different compliance standards? Yes, okay, then it looks like we met all the gates. And then we cycle that with the observability piece right at the bottom, because security is a continuous improvement. It's not like we basically deploy policy once and then expect it to work forever. Because guess what? Vulnerabilities show up every day. Every day when you look at those image scans, there's a new vulnerability that pops up. So that means you have to change your base image, which means a rebuild, which means this cycle is endless. It doesn't stop. So to summarize, spend some time addressing the security in your own environment. You might be running Windows NT today and not know it. Or not. Maybe you're running a highly secure environment that no one has access to, no one knows about, no one knows the location, only one person has the keys to the closet. That could be another option too. Or maybe it's hidden somewhere in the cloud and it's not obscure in any way, shape, or form. So it's challenging to try and do this, but with the right tooling like Kubescape, you're able to identify this. But it also means you have to talk to the different parts of your organization so that they're on board with the policies that need to be implemented, the approaches that need to be taken, the tooling that needs to be purchased or leveraged to be able to achieve all of those security goals, and then the life cycling of it as well. And then finally, use the trio of Kubescape, Istio, and Cilium if you want to achieve some of that remediation from a networking standpoint. I don't work for Armo, but I'm just going to be there's Armo if you want to know more about them. They were founded in 2019. Check out their website. Check out their stuff. They really got a good security practice going on. They're a sandbox project right now. And I suspect over the next probably year or so, they're going to form a deep level of partnerships with a lot of vendors to be able to help them remediate and configure their solutions, tune them appropriately so there is conformance. And then I work for Solo. So I'm a developer advocate at Solo, but the company was founded in 2017, and they started off in the API gateway and API management space. But as API gateways evolved to service mesh, Solo followed that along too and provides abstraction on top of service or Istio service mesh in addition to CNI. If you want to learn more about some of these technologies, if you want to learn more about maybe some of the application networking stuff, go to Solo Academy. If you want to learn more about Kubescape, check out this QR code over here and reach out to the folks there. If you want me to connect you with Rotem or anyone at Armo, let me know and we can get you talking. Any questions? No questions are good questions. All right, thank you very much and have a great evening, everyone.